No one allowed.
So right triangle trigonometry, and sorry for those of you that learned this last year, but it never hurts to have a refresh. Right triangle trigonometry is used a lot in pre-calculus, calculus, and physics. A lot in physics. So it is used to help you find missing side lengths. We'll also learn tomorrow that there are inverse trig functions that can help us find angle measurements. So this is really useful when it's, say, not a 30, 60, 90. Let's say it's a 40, 50, 90. And we only know one of the sides, but we know an angle. We can use right triangle trig to find those missing side lengths. So what it says up here is that you can use trig ratios. Trig is just short for trigonometry, so you don't have to write that out every time, to find missing side lengths. And this should be in a right triangle. The sine, cosine, and tangent functions do not work for non-right triangles, so they have to be right triangles. All right, so this is the acronym that will help you identify what the trig ratios are and what their relationship is. So first of all, let's come down here. This is what they are, and you see these on your calculator, SIN, COS, TAN. What this stands for is the sine function, pronounced sine, S-I-G-N, like a sine, you would see. Please don't call it sin. Okay, I know the abbreviation is SIN, but it is the sine function. You want to write it phonetically, sine function. The COS is an abbreviation for the cosine. Again, pronounced cosine. Cosine. The last one is our tangent, which is pronounced exactly as you would think, tangent function. Okay, there are also 3 reciprocal identities, but we don't learn those in geometry. You will see those in pre-calculus. So what these stand for are they are trig functions that relate sides of a right triangle with its angle. So theta, right here, is a variable that's representing an angle. So instead of putting an x, which you will see x sometimes, they can put Greek letters. So theta is a Greek letter that they often use in trigonometry to represent an angle measurement. So it just looks like a 0 with a line through it. Okay, that's our theta. So SOHCAHTOA, the phrase SOHCAHTOA, is kind of like PEMDAS. So all it is an acronym to help you memorize what goes with what. Now before we tell you what these letters stand for, let's label them on the triangle. So the opposite, adjacent, and hypotenuse are the sides that represent the SOHCAHTOA ratios. They're all in regards to where theta is. So the opposite side will be the side that is across from the angle. So label this your opposite. The adjacent side is the side that is beside theta. That is a leg and not a hypotenuse. So we would call this the adjacent side. Lastly, our larger side is always our hypotenuse. Hello? He's taking a test for me. He's in another room. Okay, so the trig ratio SOHCAHTOA, I like to write it like this. The sine function is our SO. Sine is opposite over hypotenuse. The ka in SOHCAHTOA is adjacent over hypotenuse. And the TOA tells us that tangent is the opposite over the adjacent. So this is just an acronym to help you remember what goes over what when I see sine, cosine, or tangent. Oh, these were supposed to go here. We'll just rewrite them then. Sine, cosine, and tangent. Sorry. And then when we're asked to just find the ratio, you literally will just have a fraction, reduced fraction, to represent the sine function. When we know what theta actually is, we'll be able to use the sine function in our calculator to find what a missing side or both missing sides are. So the first few examples just ask us to find the three trig functions using the triangle below. Okay. Now again, opposite, adjacent, hypotenuse will move depending on where the angle is. So if this is the angle, 3 would be my opposite, because it's across from the theta. 4 would be my adjacent, and 5 would be my hypotenuse. So to find out what the sine, cosine, and tangent functions are, all we do is we use our SOHCAHTOA ratio. SOHCAHTOA. So the sine function is the opposite, which is 3, over the hypotenuse, which is 5, 3/5. The cosine would be what? Marquise? 4/5. And the tangent would be? Tangent would be, Aaron, what do you think? Opposite over adjacent. 3/4. Now let's suppose that you got, I don't know, 8/10. You would want to reduce any ratios to the simplest form. All right, now the next one. Label our triangle. What would the opposite side be this time? What would the opposite side be? Would it be the 15, the 20, or the one that doesn't have a number on it? Justin, what do you think? Which side would be opposite? The 20 inches. Very good. Theta's down here, so 20 is opposite. Which would make 15 what? The adjacent or the hypotenuse? Lexi? Adjacent. Now, problem, we don't know what the hypotenuse is. How can we find it? Luke? Pythagorean theorem. Very good. 15 squared plus 20 squared equals c squared. This is also a triple. This is a 3, 4, 5 times 5, which gets you a 15, 20, 25. So triples are still going to show up a lot, even in the rest of chapter 8, and even into some of our next chapters. So if you wanted to do Pythagorean theorem, you could. You'll end up getting 625, square root it, and you'll get 25. So put that on our picture. So now again, we use our SOHCAHTOA ratio from up here. So sine is opposite, 20, over hypotenuse, 25. Now we do want to reduce that. So 20 over 25 reduces by a factor of 5, and we will get 4/5. What would the cosine be? Adjacent over hypotenuse. Adjacent over hypotenuse. Justin? 3/5. We'll get 15 over 25 to start. Adjacent over hypotenuse, 15 over 25, reduced by a factor of 5, we get 3/5. And the tangent? Lexi? 4/3. Very good. 20/15, which is 4/3. Some students notice that whenever they are 3, 4, 5 times whatever, you actually could just reduce them all to 3, 4, and 5 first, and then do the ratios instead of having to reduce at the end. So that's something you can notice. All right. Now in the next few, and I don't know if theta is actually drawn on your paper or not. Is it? Is this where theta is on your paper? Okay, because on mine it's like hand drawn in. Why don't you see if you can complete all of these, and we'll pair share. Make sure you're careful with what you label opposite, adjacent, hypotenuse, because the theta is moving around. So I'll start you off. The opposite side for the first one would be 12. The adjacent side would be 5, and then the hypotenuse will be 13. Remember, these all depend on where theta is. Okay, let's see who I haven't heard from yesterday. Chet, what did you get for A? Just read all of them down for me.
12/13.
Yes?
13. 12 over 5.
Good. How about B? Lauren?
3/5.
Yep.
4/5, and 3/4.
Perfect. So this was originally 6/10, which reduced to be 3/5. This was 8/10, which reduced to be 4/5, and this was 6/8, which reduced to be 3/4. Again, if you wanted to, and you notice that this is a 3, 4, 5 times 2, you can actually reduce the sides down to 3, 4, 5 first, then label opposite, adjacent, hypotenuse. Make sure, again, here's the angle, so the opposite side was here, the adjacent side was here, and the hypotenuse was there. So theta is going to move around. Don't always think that opposite is the top or the bottom, left or right. There's no pattern. And our last one, Jess, what did you get for the last one?
24/25.
Good?
7/25. And 24/7.
Perfect. So in this case, our opposite was 24, adjacent was 7, hypotenuse was 25. Hypotenuse is always going to be your longest side step. Okay. Now in the back, what we're going to do is we're going to take away some of the numbers, but we are going to throw in some of the angle measurements. What you'll be able to do then is find out a missing side length. Now before we do that, I want to make sure all of us know how to use the calculator, because the calculator can give you the wrong number if you're in radians, which my pre-calc students, in case you have to switch to radians for that class, make sure when you come back here, you switch back to degrees. So for anyone that has a graphing calculator, press the mode button, which is right up top, second one over, and make sure that it's in degree mode, not in radian mode. Right now mine is in radian mode. So I would arrow down, arrow over to degree, and hit enter until it's blinking and solid on the degree. I believe these have the ability to do radians as well, so maybe not. Oh, it does. So a lot of you have this calculator, different colors, but same one. If you notice, the second button says DRG, which is degree. If you press that, it's automatically in degree mode. If you arrow over, it will go to radians. We don't want to do that for this class. So it should be fine. It'll just stay in degree mode. But again, graphing calculators can somehow in your backpack get switched if you don't put the case on. So especially for a quiz or test, always make sure you're in degree mode. Otherwise, you're going to get every single question wrong. Okay. Okay. Go back to my mode, make sure it's saved. All right. So now let's just practice finding the sine, cosine, and tangent of these values to make sure that our calculators are all getting the same numbers before we move on. So just press the sine button and type in 40 for 40 degrees. And they want us to round to the nearest tenth. So this would be 0.6. Who is not getting 0.6? Second mode, which is good. Anyone not getting 0.6? All right, try cosine of 18. What would this be rounded to the nearest 10? Brett? 1.0. 1.0. 0.95, 5 rounds the 9 to a 10, so 1.0. Tangent of 27. We should be getting 0.5. Anyone not getting those numbers or not finding the buttons on their specific calculator? Okay. Now, we're going to take and apply this to geometry problems. So what you're going to notice in these pictures is that we have an angle and a side given to us. We are going to be able to use either the sine function, the cosine function, or the tangent function, and we'll be able to figure out what W is. We actually could then find the other side as well using one of the other trig ratios, or also using Pythagorean theorem. So the first thing that I want you to do is I want you to label, I want you to get rid of the word all, okay? I want you to label the sides as opposite, adjacent, and hypotenuse, okay? And then I'm just going to put a little asterisk. Only label the sides that have numbers or variables. It will make it easier for you. So do not label the side that has nothing on it, because it's not going to help you. Once you've labeled the sides as O, A, and or H, you will choose which trig function should be used using your SOHCAHTOA. Lastly, you'll solve for x using inverse operations. Okay, so for example 2a, this is like your theta. 54 is now your theta. So what would I label W? Opposite, adjacent, or hypotenuse? Marquise? Opposite. Do not label this adjacent because there's no number on it and there's no variable, so that side is not going to help you. We would label 17 with hypotenuse. Okay, again, do not label the other side. Which trig function uses O and H? Sine, cosine, or tangent? Sine. Sine is opposite over hypotenuse. Okay? So, normally I won't show this much work, but for the first one I will. So the sine of any angle theta is equal to opposite over hypotenuse. What you'll do then is you'll substitute in what you see from this problem to be the angle, the opposite, and the hypotenuse. So the angle itself is 54, so this will be sine 54 equals, opposite is W, over hypotenuse, which is 17. Normally this is like the first thing I would write down. I won't write the formula, but just for our notes, so you can see it, where this is all coming from. Now once you get to this step, you're following inverse operations to solve. So if I want to solve for W, what would I have to do to both sides? Multiply by 17. I see division. That's what this division bar is. So I'm going to use inverse operations. And I'm going to multiply by 17 on both sides. Now, this goes into your calculator. You do not want to do one part, round it, and then multiply by 17. You want to type the whole thing into your calculator. So, 17 times sine 54. Then hit enter. Do not round the sine of 54 and then multiply it, because you will get a rounded answer then. So I get 13.75, and what are my directions here? They don't tell me. Let's do nearest tenth again, just like we done the last one, so this would be 13.8. Alright, next one, label your sides based on where the angle is. And this is the angle that they're talking about. So what would I label the 1.0? Is that opposite, adjacent, or hypotenuse? Abby, what do you think? Would this be the opposite, the adjacent, or the hypotenuse? Opposite. And how about the W? No, what do you think I would label W? Adjacent or hypotenuse? Based on this angle. Would this be my adjacent side, or would this be my hypotenuse? Careful. Hypotenuse is my longest side. The longest side would be this one. So this would be my hypotenuse. So this has to be my adjacent. I would not write hypotenuse here. Again, it's going to trick you into picking a trig ratio that you don't know anything about the hypotenuse. So only label the two sides that you have marked. Then go to your trig ratios, SOHCAHTOA. Opposite and adjacent is my tangent function. So I'm going to say tangent of theta equals opposite over adjacent. That's the formula for tangent. Again, you can skip this on your homework if you'd like to, but for your notes, just so if you look back, you understand where the heck all this stuff came from. Substitute in, theta is the angle, so that's tangent of 28 degrees, technically, equals opposite 1.0 over adjacent W. Now, put a couple stars here. This is the harder case to solve. Takes 2 steps instead of 1. What do you think I would do to solve for W? Would I just divide by 1 on both sides? If I divide by 1, those would cancel out, but I would be left with 1 over W. And I don't want that. I want to know what W itself is. So what you actually need to do is undo division of W with multiplication of W. Just like you did in the other one, but the other one happened to be a number and then you were done. So I'm going to get W times the tangent of 28 equals 1.0. Now, tangent of 28 is just a number. It's a number with decimals, but it's a number. So just like we can undo division with multiplication, we can now undo multiplication with division. So you will actually divide by the tangent of 28. I know it looks weird, but you do want to leave it in this format so that we don't round any answers. Now this part goes into our calculator. So in the calculator, we're going to have 1.0 divided by, so press the division bar, tangent 28. If you want to close the last parenthesis, you can, but since we're not typing anything after, it doesn't matter. So 1 divided by tangent will get me 1.8807, which would be 1.9. So W equals 1.9. Okay, last one. Here's my angle. What would W be? Opposite, adjacent, or hypotenuse? Justin?
Adjacent.
Adjacent, excellent. And 4.5 would be my hypotenuse. So coincidentally enough, I have one of each of shown in the examples. We have sine, tangent. Now we have our cosine. Again, do not label that, because otherwise if you label this opposite, you might not know which one to pick. So now we'll have cosine theta equals adjacent, oops, I'm skipping steps, just writing my formula, over hypotenuse. Again, if you want to skip this on the homework, you don't have to write this out every time. Sub in your values, so we'll have cosine of 33 equals, adjacent is W, hypotenuse is 4.5. This is the easier one to solve because W is in the numerator. So we just use our inverse operations. We see division of 4.5. We do the inverse, which is to multiply by 4.5. And then this whole thing goes into my calculator. 4.5 times cosine of 33. Oops. Hit enter, and 3.77, which would round to 3.8. Now you will see some on your homework that are a little bit harder. You may have to use sine and cosine in a problem that has like triangles back to back. And that might not be till tomorrow actually, but you will see some that challenge you a little bit more than this. See if you can complete the closure, finding the value of x in both of